All right, thank you for being responsible and making up this lab. So this is part 2. So yesterday we had focused on the idea here that air moves from high to low, and that when particles are closer together, they're under higher pressure. When they're further away, they're under lower pressure, and that is a result also of temperature, that when particles are moving slower because they're colder, they have less collisions, so they're closer together. When particles have a high temperature, like right here, particles move faster, they have more collisions, and they spread out, so they are lower pressure and they are less dense. We then talked about how if the temperature is higher, the pressure is lower, and if the temperature is lower, the pressure is higher. So it's an indirect relationship. As temperature goes down, pressure goes up. As temperature goes up, pressure goes down. We then yesterday also talked about how this area here, the equator, has the lowest pressure because it has the highest temperature. And remember, it's an indirect relationship. So the higher the temperature, the lower the pressure. Here we also said the poles would have the opposite effect. So they are the lowest temperature, so therefore they would have the highest pressure. We then thought when we looked at 30 degrees north and south, those are going to be cooler than the equator, so we have a high pressure area. And then here at 60 degrees north and 60 degrees south, we have another low pressure area. And so then we noticed that there was a pattern. It was high, low, high, low, high, low. Well, we remember that air moves from high to low pressure. So when we looked at winds, we noticed that the wind goes from high to low, high to low, high to low, high to low. So this is the direction of the wind. And remember that winds are named by where the wind starts. So if it starts in the south, we call it a south wind. If it starts in the northeast, we call it a northeast wind. So a north wind starts from the north and goes toward the south. So let's look at the other questions. Air moves from blank pressure to blank pressure. Think to yourself, make sure that you always pause as we go. That would be high pressure to low pressure. Therefore, if we did not have any change in pressure, we would not have wind. So a change in pressure causes the wind. But then it's like, well, why do we have a change in air pressure? Why is this low pressure and this is high pressure? Well, let's talk about that first. Why is it that this has lower pressure than this? Well, it has to do with the temperature. So, a change in pressure is caused by a change in temperature. If the temperature did not change, then the pressure wouldn't change. But since our Earth is constantly changing temperatures, our Earth is also constantly changing pressures. So why is this part warmer, than this part here? Well, think about first quarter when we were talking about the flashlights and how the Earth is heated. The Earth is unequally heated. So certain areas of the Earth get more direct sunlight, like the equator does, and some parts get less direct sunlight. So there is indirect and direct sunlight. And why do we have such a big difference in the seasons? And the Earth is tilted. That's all from first quarter. So therefore, we're going to always have winds because winds are caused by that change in temperature and our Earth is unequally heated. So if you notice here, it seems like it should go from a straight line from the high to the low pressure, but it doesn't. It has a slight curve. So if you look here, the wind is curved. It's not in a straight line. Well, if it's trying to go from high to low pressure quickly, it doesn't make sense that it's not a straight line. So I want you to pause this video and I want you to think about, why do you think the winds are curved? Remember, it's a why do you think question. So you're thinking about what you've learned up until this point in our studies, and you're just making a good guess. It's okay if you're incorrect, but please pause and write in your answer. And then press play when you're done. All right, so you should be now played. You should have this part filled in. So let's look at this part here. Why is it that the winds curve? Well, our Earth isn't still. Our Earth is constantly moving. Remember, we revolve. That's where we go around the sun. And we also rotate. We spin. The spinning causes us to have curved winds. If there was no spinning, if the Earth did not rotate, the winds would not be curved. And this is called the Coriolis effect. The Coriolis effect is winds curve because the Earth rotates. We also discussed in class about when you look at an airplane, like a path of an airplane, it's always got that curve. It's because of the Earth's rotation, and that's the Coriolis effect. Now, all of these have different names. These winds that we look at, they're coming from the poles and mostly from the east, so we call these the polar easterlies. These ones right here, they're mostly starting in the west, so we call these, and these down here, the prevailing westerlies. And these we call the trade winds, because way back when they relied only on the sails to carry the boat with the wind, they relied on this to go trade goods. Remember, from social studies, trading means a exchange of goods. So they would bring something and get something in return. So those are called the trade winds. These are called global winds because they blow across the entire globe. However, there are also something called local winds. So if you flip your paper over, we're now going to look at local winds. Local winds blow over a short distance, like maybe from Chicago to Bloomington. Global winds are a long wind, maybe one that would blow from Canada down into Mexico. Okay, so the question we have here is, why does the wind blow from the land to the sea, and why does the wind blow from the sea to the land? Well, the first thing we have to do is we have to name them. One of these is called a land breeze, and one is called a sea breeze. To help you out a little bit, I'm going to label a few things. This is the sea. Please label with me. This is the sea. This is the land, and this is the land here. Okay? This right here, this arrow, is the wind. This arrow here is also the wind. And it is important to notice that this is during the day, and this is during the night. So if you stand by the ocean or a large body of water, you'll notice that it's a little bit windy. This is an example of a local wind. Well, let's go ahead here, pause your video, and write in one of these is called a sea breeze, and one of these is called a land breeze. And I want you to make a guess about which is which. Remember, breeze is just another name for wind. Please pause. When you're done, press play. Okay, so let's look at this first one. This one, if you put land breeze, you are correct. It is a land breeze because it is starting in the land. And this is a sea breeze because it is starting in the sea, starting at the water. See how it starts here and moves this way? Now I want you to think, where's the high pressure, where's the low? Pause your video and write what you think. Make sure to pause so you make your predictions. Okay? If you said that this is high and this is low, you are correct, and that makes sense because it moves from high to low. Therefore, this one must be high and this one must be low pressure because it always moves from high to low. Now pause the video and write where you think the temperature, high temperature, cool, and warm are. Okay? Press play when you're done. If you said high pressure goes with cool, you are correct. Low pressure goes with warm from the other side here. Now this one would be warm, and this one would be cool. So now let's go ahead and look at our questions. Why does the wind blow from the land to the sea in diagram X? Well, here the land is cooler, and the land is cooler because land cools quicker than the water does. So if you ever go to the beach at night during the summer, the water will actually seem warmer than the land because the land cools off quicker. Now let's look at this one. The land now it is now heating up quicker. So the land heats up quicker than water. That's why when you go into the water during the day, it feels really good. It's nice and cool, and the land is warm. And since this is warmer and this is cooler, the wind's going to blow this way. Okay? This at night, when the water is a little warmer, the air above the water is warmer, it's going to then move from the land to the sea. Okay? So the first winds were global winds. The ones above that I just talked about are local winds. So I want to know the difference. One of them blows over a long distance, and one of them blows over a short distance. Go ahead, pause the video, and write what you think. Okay, now comes the reflection. In this one, I want you to draw me some arrows, okay? So I want to know, use your resource of this activity to help you. You're going to draw in a couple of arrows for me, okay? And I want you to think about the direction of that arrow, okay? So fill in the rectangles with the arrow in the correct direction. So the first one, high pressure. Does high pressure move to low pressure like this, or does low pressure move to high pressure? That's the first thing, okay? Second one, high pressure, does that go with high temperature, or does high pressure go with low temperature? And then over here, does low pressure go with low temperature, or does low pressure go with high temperature? You are also fine to write high, low, higher, low here. Then, once you have filled in these, I want to know, does it move from this way with the temperature, or does it move this way? Okay? So you need to fill that in on your own. Okay? Then right here, all I want you to do is I want you to explain to me the basics about how, when, and why winds move. So I'm looking for you to explain from blank to blank pressure, from blank to blank temperature. Okay? So I'm curious to see what you remember and what you understand about how winds move. So at this point, you should stop the video, and you're going to fill in the reflection, and then you're going to make sure your name's on your paper, double check your work, and make sure to see me if you've got more questions. Feel free to rewind and watch parts of this video again, so that you feel good and ready about understanding winds. Sorry, my little lights go off. All right, nice work, and please see me if you have any questions.